Why is it that mains power is AC, but the circuit boards in your computer use DC? Originally, all domestic electricity was DC. This worked well when it was used to power houses and factories near generating stations, but after a mile or so, the power lines heated up so much that they didn't deliver much power. By using a transformer, you could increase AC voltages to hundreds of thousands of volts. This reduced the current in the power lines and stopped them heating up so much. Once you could transport electricity over long distances without losing power, you could build generating stations as large as possible where land was cheapest and send their power to where it was needed. The national grid connects all the UK's power sources to balance electricity supply and demand. Of all the thermal power stations, nuclear and coal take the longest to warm up to full power. So they are kept running 24 hours a day. Because of this, they supply a constant, continuous amount of power to the national grid, supporting what's known as the base load. Oil and gas have the shortest warm-up times, so are used to deliver extra electricity at peak demand, with renewables and imports making up the rest of the supply to the national grid. A huge transformer steps up the voltage from 25,000 volts to 400,000 volts, so it can travel up to 300 miles without losing much energy. And when the power arrives at a substation, it's stepped down to around 7,000 volts by another transformer. In most areas, the local power lines run underground to a small box, where another transformer steps the voltage down to between 230 and 240 volts for your plug socket. Some household appliances, including your light bulbs and kettle, can run on AC or DC, but anything that contains microchips or circuit boards only works properly if the current flows in one direction, and they need a component called a diode to convert AC to DC.